Hello students. So in this video, let's find the area of a triangle. Okay. Suppose if the vertices of the triangles are given, that the coordinates of the vertices, let's say we have got a triangle. Let's take a triangle. Okay. A, B, C. Let's say the coordinates of A is x1, comma y1. And let's say the coordinates of B is x2, comma y2. And let's say the coordinates of C is x3, y3. Okay, here they have given us the coordinates. Now using this coordinates itself, we can find the area of the triangle. Okay, so area of triangle, which is a triangle here, ABC, that will be equal to, let's shift this a bit this side. Okay, so area of triangle ABC is equal to, it's very easy to remember, half into, write it like this, x into y minus y, 3 times, x into y minus y plus x into y minus y. Okay, now place the 1 2 3 in cyclic order, that is the suffix 1 2 3. Now start from 2 2 3 1. Now from 3 3 1 2. Okay, it's like the cyclic order. Okay, first start from 1, then 2, then 3. Okay, 1 2 3, then 2 3 1, then 3 1 2. Okay, it's very easy to remember. So this is the formula to find the area of the triangle. Okay, if the 3 coordinates of the triangle are given. And one more very important use of this formula is you can check whether the points are collinear or not. Now basically, what do you mean by collinear? Points are said to be collinear if they lie on a same straight line. If they lie on a same straight line or a single straight line. Okay, for example, let's take points like this. Okay, all these points can be connected by a single straight line. Therefore, these points are collinear. But for example, if I take points like this, can I connect all the 3 points using a single line, a single straight line? No, that's not possible. So you can connect these two by a line, and to connect these two, you need a new line, isn't it? Therefore, you cannot connect all these points by a single straight line. Therefore, the points are not collinear. And remember one thing, if the points are not collinear, okay, I'm talking about 3 points. If 3 points are not collinear, then you can form a triangle out of it, isn't it? But if the points are collinear, can we form a triangle? It's not possible, isn't it? Therefore, if you're not able to form a triangle, if the points are collinear, you won't be able to form a triangle. If you're not able to form a triangle, then what is the area? Basically, there is no triangle here. Therefore, the area comes out to be 0 because there is no triangle, isn't it? So using this formula, we can check whether the points are collinear or not. If the points are collinear, then the area of the triangle comes out to be 0, because if the points are collinear, we cannot form the triangle. If we cannot form the triangle, the area will be 0, isn't it? So therefore, if three points are said to be collinear, remember 2 points are always collinear because you can connect 2 points by a single straight line. So collinear, when we talk about collinear, it is 3 or more than 3 points. Okay, 3 points are said to be collinear if area of the triangle, is equal to 0. Okay, very, very important. If the area is not 0, then the points are not collinear. Okay, so that's an important note. Let's get into the first question. There are 2 sub questions. Find the area of the triangle 2, 3, minus 1, 0, and 2, minus 4. So let's take the first coordinate as A, which is 2, 3, and let's take the second coordinate as B, minus 1, 0, and let's take the third coordinate as C, 2, minus 4. So as you all know, x1 is 2, y1 is 3. x2 is minus 1, y2 is 0. x3 is 2, y2 is negative 4. Therefore, the area of the triangle is given by the formula area of triangle ABC is equal to, as I told you, half into x y minus y 3 times plus x y minus y plus x y minus y 3 times. Okay. Now let's substitute the values. Half, and after this we have to write the numbers in cyclic order. 1 2 3 2 3 1 3 1 2. Okay, sometimes students make this as 3 to 1. You have to be careful. It should be in cyclic order. 1 2 3 2 3 1 3 1 2. Okay. Now what is our x1? x1 is 2. y2 minus y3. y2 is 0 minus y3 is, sorry, this is y3. y3 is minus 4. So already there is a minus, again a minus. So minus of minus becomes plus. Okay. What is our x2? x2 is minus 1 within the bracket. y3 is minus 4 minus y1 is 3. Plus again x3 is 2, y1 is 3 minus y2 is 0. Now let's simplify it. Half 2 into 0 plus 4 is 4. Plus into minus is minus 1. Minus 4 minus 3 gives us minus 7 plus 2. 3 minus 0 is 3. So it becomes half. 2 4s are 8. Minus into minus plus. So 1 into 7, 7. 2 3s are 6. So it becomes half. 8 plus 7, 15. 15 plus 6 is 21. So half into 21. It becomes half into 21 is how much? 10.5. So therefore, area of the triangle, area of, okay, let me repeat it again. So we are finding the area of the triangle ABC. So I have written the formula for area of the triangle, half into x1 y2 minus y3 plus x2 y3 minus y1 plus x3 y minus y2. We know how to write the formula. I have substituted the value. We have got area as half of 21. Half of 21 is 10.5. Therefore, area of triangle ABC is 10.5 square units. Okay. Similarly, let's do the other sub question. So the other sub question, A value is, let me first draw a straight line. Okay. So here, let's take the first coordinate, A minus 5 comma minus 1, B as 3 comma minus 5, and C as 5 comma 2. Okay. So here x1 is minus 5, y1 is minus 1, x2 is 3, y2 is minus 5, x3 is 5, y3 is 2. Now let's write the formula for area of triangle. Area of triangle ABC is equal to half 3 times x of y minus y plus x of y minus y plus x of y minus y. 3 times we are supposed to write it like that. Let me move this a bit. X of y minus y. Now let's substitute. And after this, we have to write the numbers in order. 1, 2, 3, 2, 3, 1, 3, 1, 2. Okay. Half x1. x1 is what? Minus 5. y2 minus y3. y2 is minus 5 minus y3 is 2. Plus x2. x2 is 3. y3 is 2 minus y1 is minus 1. So minus of minus becomes plus 1. Plus x3 is 5. y1 is minus 1 minus y2 is minus 5. So minus of minus becomes plus 5. Okay. So let's simplify it. Half minus 5 minus 5 minus 2 is minus 7 plus 3. 2 plus 1 is 3 plus 5 minus 1 plus 5 is 4. So half minus 5 into minus 7 is 35. Minus and minus plus 5 7s are 35. 3 3s are 9. 5 4s are 20. Okay. Half 35 plus 9 44. 44 plus 20, it becomes 64. Half of 64 is 32. Therefore, the area is 32 square units. Okay, that's the area of the triangle. Very easy. We have to find x1, y1, x2, y2, x3, y3, and write the formula, memorize the formula, and substitute it. Okay. Similarly, let's get into this. In each of the following, find the value of k for which the points are collinear. And one more thing, in exam, if they ask you to find whether the points are collinear, okay, they give you 3 points like this. Let's say 2, 3, minus 1, 0, 2, minus 4. They give you 3 points like this, and they ask you to find whether the points are collinear or not. We have to follow the same procedure. We have to find the area. If the area comes out to be 0, if the value of the area is 0, then the points are collinear. Otherwise, it is not collinear. As you can see, in both the cases, the area is not 0. Therefore, the points are not collinear. So let's get into the next question. So here, we have to find the value of k for which the points are collinear. They've already mentioned that the points are collinear. What we have to do is we have to just find the value of k. So let's do that. So here, let's take the first point as a, 7, minus 2. Let's take the second point as b, 5, 1, and let's take the third point as c, which is 3, k. Now, x1 will become 7. x1 is 7. y1 is minus 2. x2 is 5. y2 is 1. x3 is 3. y3 is k. Now, let's use the formula of area of triangle itself, because if the points are collinear, area of triangle is 0. Isn't it? First, let's write the formula. Area of triangle is given by the formula half. Remember, you have to write it 3 times like this. X of y minus y plus x of y minus y plus x of y minus y. And now the suffix 1, 2, 3, 2, 3, 1, 3, 1, 2. Okay, now let's substitute. Since the points are collinear, area of triangle is 0. 0 equals half. x1 is 7. y2 is 1 minus y3 is k plus x2. x2 is 5. x2 is 5. y3 is k minus y1 is minus 2. So minus of minus becomes plus. x3 is 3, y1 is minus 2, minus y2 is 1. Now, let's transpose 2, which is outside the bracket. This 2 to the other side. Okay, it's a common term for everything, so I can put it the other side. So it becomes 0 into 2 equals, okay, 7 into 1. 7 into 1 is 7, minus 7 into k, 7k, plus 5 into k, 5k, plus 5 into 2, 10, plus 3, minus 2 minus 1 is minus 3. Now 0 into 2 is 0 equals 7 minus 7k plus 5k plus 10. 3 into minus 3 is, sorry, 3 into minus 3 is minus 10. Zero equals 7 minus 7k plus 5k will become minus 2k. 10 minus 9 is 1. Okay. Now you can further simplify this. 7 plus 1 is 8. So 0 equals 7 plus 1 is 8. 8 minus 2k. So minus 2k, the other side will become plus 2k. 0 plus 2k is equal to 8. So therefore 2k is equal to 8, which implies k is equal to 8 by 2. 8 by 2 is 4. Therefore the value of k is 4. So it's very simple. They've given you 3 points, which is x1, y1, x2, y2, x3, y3. Substitute in the formula of area of triangle. Area of triangle is 0. So you have to take the value as 0. So directly you'll get the value of k. Second sub question, you can take it as a task and you can try it by yourself. So let's get into the next question. Find the area of the triangle formed by joining the midpoints of sides of the triangle whose vertices are 0, comma minus 1, 2, comma 1 and 0, comma 3. Find the ratio of this area to the area of the given triangle. Now what we have to do is we have to find the area of the triangle formed by joining the midpoints of the sides of the triangle. Okay, first they have given us a triangle. Let's draw a triangle. Let's say this is the triangle, which is A, B, C. Okay, and they have given the coordinates, which is 0, comma minus 1, B is 2, comma 1, and C is 0, comma 3. Now the coordinates of this triangle is given. Let's take D is the midpoint of AB, okay, and E is the midpoint of BC. E is the midpoint of BC, and let's say F is the midpoint of AC. Okay. Now what we have to do is we have to find the area of this triangle that is formed by joining the midpoints. Okay. So that is, we have to find the area of the triangle DEF. Also, we have to find the ratio of the original triangle and the new triangle, that is DEF triangle. Okay. Now, what we'll do is we have to find the coordinates of DEF, because if you know the coordinates of the vertices of the triangle, you can easily find the area of the triangle, isn't it? So to find the coordinates of DEF, it's very simple. Coordinates of D. Okay. D is the midpoint, right? So we are going to use midpoint. Coordinates of D is equal to, the formula will be x1 plus x2 divided by 2, comma y1 plus y2 divided by 2. D is acting as midpoint for what? AB, right? So x1 will be 0, x2 will be 2 divided by 2, comma y1 will be minus 1, y2 is 1 divided by 2. So if you observe, this is A will be x1, y1 and B will be x2, y2. Okay, that's what I've applied here. So 0 plus 2 is 2 by 2. Minus 1 plus 0 is 0 by 2. So 2 by 2 is 1. 0 by 2 is 0. So we got the coordinates of D. Okay. Coordinates of D is 1, comma 0. So similarly, let's find coordinates of E. Let me directly do it. Coordinates of E. So as you can see, E is again a midpoint. So we have to add x1 plus x2. x1 is 2, x2 is 0. 2 plus 0 is 2. By 2 gives you 1. So 1, comma y1 plus y2. So that is 1 plus 3, 4. If you divide it by 2, 1 plus 3 is 4. 4 by 2 is 2. So coordinates of E is 1, comma 2. Now let's find coordinates of F. Again, x1 plus x2. x1 is 0, x2 is also 0. 0 plus 0 is 0. 0 by 2 is 0. Comma. y1 is minus 1, y2 is 3. Minus 1 plus 3 is plus 2. 2 by 2 is 1. So we have got all the coordinates. Now let's find the area. Okay. Area of triangle DEF. What will be the formula? Half into x, y minus y plus x, y minus y plus x, y minus y. And let's substitute the formula. Half, and we have to put the suffix 1, 2, 3, 2, 3, 1, 3, 1, 2. Okay. So here, let's take D, coordinates of D as x1, y1, coordinates of E as x2, y2, and coordinates of F as x3, y3. Okay. So x1 is 1, y2 is 2, minus y3 is 1, plus x2 is 1, y3 is 1, minus y1 is 0, plus x3 is 0, y1 is 0, minus y2 is 2. Okay. So it becomes half. 1, 2 minus 1 is 1, plus 1. 1 minus 0 is 1 itself. 0 into anything is 0. So you get 1 into 1 is 1. Again, 1 into 1 is 1. So you get half into 2. Half into 2. That's what we get. Let me push this down a little bit. So what we get is half, 1 ones are 1, 1 ones are 1 plus 0. 1 plus 1 plus 0 is 2. So 1 by 2 into 2, 2 gets cancelled. Therefore, area of triangle DEF is equal to 1 square units. Okay. We have found the area of the triangle formed by joining the midpoints. Now we have to find the area of the original triangle. Okay. So that is area of the triangle ABC. Area of triangle ABC. So half, let me write the formula. Half x y minus y plus x y minus y plus x y minus y. Okay. And the suffix 1, 2, 3, 2, 3, 1, 3, 1, 2. Okay. And let's substitute it. Half. So let's look at the equation. Okay. So let me write it in the question itself. This is my x1, y1 now, x2, y2, x3, y3. Okay. Now, what is x1? x1 is 0. So 0 into anything is 0. y2 minus y3, let it be whatever. We are not worried. However, you get 0. So let me write it directly. 0 into anything is 0 because x1 is 0. 0 multiplied by anything is 0. x2 is 2. y3 minus y3 is 3 minus y1 is minus 1. Minus of minus becomes plus. Okay. Plus x3 is 0. Okay. x3 is 0. So 0 into anything is 0 itself. Again, we can eliminate this. Directly I'm doing it. So half 0 plus 2, 3 plus 1 is 4 plus 0. 2 4s are 8. So half into 8. So therefore it becomes 4. Okay. So 4 square units. Area of triangle ABC is 4 square units. Now if you take the ratio of what by what? Area of the triangle DEF. If you take the ratio, area of triangle DEF to the original one, area of triangle ABC. Area of triangle is DEF is 1. Area of triangle ABC is 4. Therefore, what is the ratio? 1:4. That will be the ratio. It's very easy. What we have done is we have found the coordinates of DEF using the midpoint formula. Once we get the coordinates of DEF, we have used the area of the triangle formula to find the area of DEF. Similarly, we have used area of triangle formula for ABC, and we have taken the ratio according to the question. So let's get into the next one. Find the area of the quadrilateral whose vertices taken in order are -4, -2, -3, -5, 3, -2, and 2, 3. Okay. Now let me take a quadrilateral. Randomly, let me take a quadrilateral like this. Okay. So I've taken a quadrilateral like this. Let's say this is A, -4, -2, and let's say this is B, -3, -5. Let's say this is C, which is 3, -2, and let's say this is D, 2, 3. Now we have to find the area of the quadrilateral, but we don't have any formula to find the area of the quadrilateral. So what we can do is we can join a diagonal so that we get two triangles. Okay. We get two triangles, one which I'm shading it in green color. Okay. As you can see, this triangle, find the area of this triangle using area of the triangle formula. Okay, that is half into x of y minus y 3 times. Okay, so you can do that. So similarly, you can find the area of the other triangle. Okay, which I am shading it in yellow color. So find the area of the triangle which is in yellow color and the area of the triangle which is in green color. Okay, using the area of the triangle formula. So let me do that. The area of triangle ABD. First, let's find ABD. What's the formula? Half x of y minus y plus x of y minus y plus x of y minus y. Now suffix 1, 2, 3, 2, 3, 1, 3, 1, 2. Okay. Now half, what is our x1? We are finding a, b, d, right? A will be x1, y1. x1 is minus 4, y1 is minus 2, x2 is minus 3, y2 is minus 5, x3 is 2, y3 is 3. So half, x1 is minus 4, y2 is minus 5, y3 is minus 3. I mean, y2 minus y3 is 3, x2 is minus 3, y3 is 3, minus y1 is minus 2. So minus of minus becomes plus. x3 is 2, y1 is minus 2, minus y2 is minus 5. So minus of minus becomes plus 5. So it becomes half minus 4, minus 5 minus 3 is minus 8, plus into minus is minus 3, 3 plus 2 is 5, plus minus 2 plus 5 is 3. So it becomes half minus 4 into minus 8, minus into minus plus, 8 4s are 32, minus 3 5s are 15, 2 3s are 6. Half 32 minus 15, it becomes 17, 17 plus 6 is 23. So it becomes 23 by 2 square units. 23 by 2 is 12.5. Sorry, 11.5. Yeah, 11.5 square units. That's the area of the triangle ABD, which we have shaded in green color. Similarly, let's find the area of the triangle in yellow color. That is area of triangle BDC. Okay, the formula will be half into x of y minus y plus x of y minus y plus x of y minus y. So half and the suffix 1 2 3 2 3 1 3 1 2 half. So x1 is, let's start with x1 minus 3, x1 is minus 3, y1 is minus 5. That is the coordinates of B. Coordinates of C will be x2 y2. x2 y2 is 3 minus 2, and x3 y3 will be coordinates of D, which is 2 and 3. So x1 is minus 3, y2 minus y2 is minus 2, minus y3 is 3, plus x2 is 2, y3 is 3, minus y1 is minus 5. So minus of minus will become plus. x3 is 2, y1 is minus 5, y2 is minus of minus, it becomes plus. Okay, so half minus 3 minus 5 plus 2 into 7 plus 2 into minus 3. It becomes half minus 15 plus 14 minus 6. Okay, half minus 15 plus 14 is minus 1. Minus 1 minus 6 is minus 7. I'm sorry, minus 7 by 2. Area is always considered to be positive, so let's take positive. That is mod A. Mod A in the sense we take only the positive, meaning the minus becomes plus. Okay, so area will become 7 by 2. 7 by 2 is 3.5 square units. We don't take the negative sign. So to find the total area of the quadrilateral, we have to just add it, isn't it? Therefore, area of quadrilateral will be 11.5 plus 3.5. That becomes 15 square units. Okay. It's very simple. You have to find the area of the triangle ABD using the formula and area of the triangle BDC using the formula. And at the last, we have to add it. Okay. So let's get into the next question. You have studied in the class 9 that a median of a triangle divides into two triangles of equal areas, isn't it? Verify this result for the triangle ABC, whose vertices are 4, minus 6, 3, minus 2, and 5, 2. I'll give it this as a task and try it at home. Okay. So what they've given us is, they've given us a triangle A, B, C. The coordinates of A is 4, -6. The coordinates of B is 3, -2. And the coordinates of C is 5, 2. Now, let's take a median. What is a median? It is a line drawn from the opposite vertex to the midpoint. Let's say D is the midpoint. Now, using the midpoint formula, you can find the coordinates of D. That will be x1 plus x2. x1 is 3, x2 is 5. 3 plus 5 is 8. 8 by 2 is 4. x2, y1 plus y2. y1 is -2, y2 is +2. -2 plus 2 is 0. 0 by 2 is 0. So, therefore, the coordinates of D is 4, 0. Now, what you have to do is, you have to find the area of this triangle, yellow color triangle. Okay. Using the formula. I hope you guys can do it. Okay. Similarly, you have to find the area of the other triangle. Okay. I'm sorry. The other triangle, which I'm shading it. Okay. Pink color. Okay. This triangle. Both you have to find the area using the formula, and remember both the areas should be equal, because D is a midpoint, okay, and AD is a median. So you have to find the area of triangle ABD and ADC and verify whether they are equal or not. 100% you should get it as equal. So I hope you guys have understood how to find the area of the triangle if the coordinates are given. The very important exercise in this chapter is finding whether the points are collinear or not. How do we check whether the points are collinear or not? Very simple. Use the area of the triangle formula, substitute all the points. If you get the final answer as 0, the points are collinear. Otherwise, the points are not collinear. Thank you, students.